Hello and good morning.
My name is Mohd bin Mohd Faisol. I'm from group T3D. My metric number is 164564. My partner is Mohd Asif bin Abdul Razak. Today I'll be conducting an overview of 1GB2 projectile motion. So let's get it started. So there are four objectives of this experiment, which is to determine the projectile range as a function of inclination angle, to determine the maximum height of projection as a function of projection angle, to estimate the value of the gravitational acceleration of the Earth, and to determine the maximum projectile range as a function of initial speed. So we will see that for the experiment part A, we will determine the first three objectives for this experiment. So experiment part A is experiment of projection. We will use 5 different angles with 3 different speed. The 5 different angle is 25 degree, 35 degree, 45 degree, 55 degree, and 65 degree. We will measure its maximum height, maximum range, and speed. With theory that theta equal to 65 degree has the highest height, and theta equal to 45 degree has the furthest range. So we will consider about the actual velocity of this experiment. So there is a distance between the middle of the light sensor and where the ball is displaced. We will use this equation to determine its actual velocity for every session in this experiment. So objective 1, we will plot a graph of maximum range against inclination angle or projection angle. So the theory that the graph should look like this. So the second one, the second objective, in this objective we will plot a graph of maximum height against angle. So the graph will basically look like where the slide show, and with 3 different speed. So for the third objective, to estimate the value of the gravitational acceleration, we will use 2 linear graphs. So the first one is the graph of height against v square sine square theta, and the second graph is rate maximum range against v square sine 2 theta. So from the slope of the graph, we will determine the gravitational acceleration. So as for example, 1 over g equal to m for the up graph, and 1 over 2g equal to m for the lower graph in this slide. So next, experiment part B is to determine the maximum projectile range as a function of initial speed. So in this experiment, we will use a constant angle, which is 45 degree, with 3 different speed. We will measure its speed and range, only 2. So the theory is that the graph should look like that, which is the graph of maximum range against its initial speed. So we will look if this graph will satisfy the equation of S equal to T cos 45 dot V naught. Okay. Few consideration questions. So for this experiment, the first question is, what do you think is the best angle of projection to start the experiment with? So in my opinion, the best angle is theta equal to 65 degree, because the scale of the angle will move like that. So it is better for us to use like that because it will move more easily. So second question is, suggest a way to accurately measure the height of projection of the steel ball in this experiment. In this experiment, we have used our mobile phone to record the maximum height of the projection. We estimate the where the steel ball is at the highest point as the ruler is displaced on the table. And then the third question is, suggest a way to determine the time taken for the projectile in this experiment to reach the maximum height. So we use this equation, which is y equal to t equals to v naught sine theta minus 1 minus half gt squared, and we will differentiate it and equal it to 0, and we'll find the value of T when we substitute the value of initial speed, angle, and the gravity. And that from the theoretical physics point of view, will the type of material of the ball affect the range and height of projection? Why and why not? So for me, my answer is yes, because of air resistance. As we can see, the formula of air resistance force is F equal to -1/2 rho AV square, where the most significant change will occur due to the density of an object. So as we can see on the right side, the graph with air resistance show a higher with air resistance show a lower value, while the graph without air resistance show a higher range and higher height. So, to explanation of question 4, the steel or wooden ball will give more accurate results? So for me, with consideration of the formula F equal to -half rho AV square, the wooden ball will give more accurate result because it has a lower mass, which indicate it has a lower density. So with lower density, it means lower air resistance. Okay. Assuming that we will use the same volume of the ball. So that's all from me. Thank you.